are in listen-only mode.
Hi everybody, I'd like to say welcome to this webinar on behalf of ECN and CDKN. We're only a small group online today, but we thought it's nice to go ahead anyway, make sure this gets recorded, and perhaps we can even have a bit better question session at the end of this. The topic that we're here to speak about today is from some recent work that ECN, together with some other organizations, has been doing in Indonesia. And in particular, the project has been focusing on energy-efficient electric motor systems. So we hope today to give you an introduction to this topic, get you excited about electric motor systems. I know from my own experience working on this, it's certainly a topic that's much bigger and more impactful than people might realize when they begin. Yeah, so in this sense, it's a really interesting topic. Just to go through a little bit, if I can get the session working, just to go through a couple of practical points as we go through. The way the webinar runs is that you're welcome to introduce yourself. There's a kind of chat box in your interface where you can introduce yourself there. There's also a feature, it's a kind of called a hands up feature, where people could nominate to pause the presentations and take a live question. We won't use that today, just in the interest of time and simplicity. We'll just go through the presentations and have some questions hopefully at the end of the session. And the way that the question and interaction works is you can also type a question to us in a dedicated section of the user interface there, and we'll collect those. If we have some, we've also got a couple of our own to pose, and we'll collect those and answer those at the end of the session. And of course, everything that gets said today and all the presentations will be made available on the CDKN website after this. Before we get into the topic in more detail, I'd like to just say a little bit about who we are as an organization. Some of you might be familiar with us. We're the Energy Research Center of the Netherlands. We're about 500 people, the largest energy research group in the country, and working on a really wide range of sustainable energy topics. So we have a lot of technical researchers really working on developing and licensing technology for biomass, or solar energy, wind energy, etc. But we also have a large policy team who work with Dutch and European governments, but also international governments as well, providing policy advice and support. And so you can see there a selection of the countries that we've worked in recent years, and also some of the sort of broad themes that we cover through our international team. And that's the team that has been working on this project in the last year and a half, and you'll be hearing from today. The actual speakers that you'll hear from, so I'm Lachlan Cameron, and I've been at ECN now just over 6 years, working in the international team on a pretty wide variety of topics. I'm only going to be giving just a really brief introduction today to the project and also to the broad concept of energy efficiency, but most of the content will be covered by Jeffrey and Martin. Jeff's a researcher at ECN, focusing on energy efficiency, in particular in the built environment. He has a lot of experience in that sense, both in the Netherlands and also in some other countries as well. Martin is a specialist advisor working for an independent agency, independent consultancy. He works on a wide variety of topics, but he also has a lot of experience specifically on motors and motor policy, and works a lot with international programs that focus precisely on motors and motor systems. Jeffrey will give more of the background to the topic. What are motors? Why are they interesting? What are some of the benefits for countries to think about that, and some of the challenges? And Martin will talk a little bit more about the policies and measures that can be taken to try to incentivize efficient motors and motor systems. So broadly, the objective of what we would like to provide today in this session, give you an introduction to energy efficient electric motor systems. What are they? How should you think about them? How can you save energy from them? And also, what are the benefits there? Talk a little bit about why are those systems not already being put in place. If you think of motor systems, you typically think here of industry or the commercial sector, and you might think of rational actors who want to do the most efficient or economically efficient thing. And yet, of course, we see that a lot of these types of energy efficiency actions are not put in place. So we'll talk a little bit about why that's happening. And then Martin, as the second speaker, will talk about the policies and in particular what kinds of measures might be appropriate in a country context such as Indonesia or other similar countries to take action on efficient motor systems. But as I said, the very first thing that we'd like to do is just give a really high-level introduction to energy efficiency and why that's interesting in general, and a little bit about why that's interesting for the industrial and commercial sectors. I guess when you think about energy efficiency, this is something that if you're listening to this webinar, I'm sure you would understand well. The way I tend to think about it is in a couple of different perspectives. I guess maybe the first perspective might be considered more of an international perspective. And here you might think of climate change and preventing climate change. And in that sense, if this is the first perspective, then the kind of background for this is really clear. We know that greenhouse gas emissions from energy are increasing really rapidly. We've seen that over the last century. This is a figure from the last IPCC report of 2014. So this is the latest consensus science and information on this. And of course, in this chart, electricity is a really big contributor to energy emissions. What we also know is that when we look inside of that and we say, well, what are those emissions that are growing over time? Then we know that here is by sector, all of the different emissions sources sort of aggregated globally. And we see on the right-hand side the impact specifically here of electricity. It's used by different demand sectors. And so when we think about efficient motors and motor systems of the type and of the size that we'll be talking about today, these are the sectors that we think about. And we can see that they're responsible for a large fraction of global emissions. And Jeffrey will also talk about just how large a component motors and their systems are within these two sectors. And I think if you're not working directly with motors, this might be something that would surprise you. Maybe just the final part of that international perspective of why is it interesting to think about energy efficiency from an emissions or climate change perspective is the idea that more still needs to be done. So what this plot shows is just a brief summary of the pledges that were brought to Paris last year. So these are the contributions that now more than 180 countries have made to the negotiations on climate change. And you can see that versus, say, the blue of where things are headed now, those promises or those contributions add up to roughly the red line over the next decades. But what you can also see is that to reach the targets that are talked about of staying below 2 degrees or even below 1.5 degrees, then we've identified or promised about half of what needs to really happen. And so that really sets the starting point for this mitigation perspective of why you would want to take action on efficient motor systems, because there is a chance there to do more. The other big perspective that's worth thinking about here in terms of energy efficiency at a very high level is about the domestic benefits that it brings to countries. And these are typically what is driving policy for energy efficiency in countries. What we see here is that there are lots of opportunities for contributing to energy security, improving competitiveness of industry, providing jobs, increasing the amount of energy that's available for energy access, a whole myriad of different domestic benefits that can come out of energy efficiency actions. And these are benefits that will be realized generally in a wide variety of countries. It's not just for OECD countries, it's not just for emerging economies. These are benefits that can be found from energy efficiency more generally. So this is a figure from a recent report from the IEA that looks precisely at this. And what they conclude is that even though many of these benefits can be difficult to monetize or to quantify, they've done some case studies there and some initial calculations, and they find that for a lot of economic energy efficiency actions, the typical benefits you're getting, or the typical sort of society returns you're getting, for every $1 of investment can be up to $4 of additional return in terms of these additional benefits. Just to dive into one of those sort of ideas in a little bit more detail, just to make it more explicit, is this idea of saving energy consumption over time and thinking about that saving as a kind of virtual supply. So for every terawatt hour of electricity that is saved, that's a terawatt hour that does not need to be produced. And that's potentially some generation capacity that does not need to be installed. Or equally, for every ton of oil that is not burned, then that's a ton of oil that does not have to be potentially imported, or a ton of coal that does not have to be dug up out of the ground. So this shows, say, what the potential success story can be from energy efficiency. So this figure is a plot of avoided final consumption in OECD countries. So that's typically industrialized or developed countries, however you might want to call them, that are members of the OECD. And the figure shows the aggregated total savings of efficiency actions, so all of the energy efficiency actions that have been taken in those countries since 1990, and their impact over time. And so what it shows is that in the most recent years, the amount of energy consumption that has been avoided is more than the total consumption of Japan and Korea put together. So that gives you a sense of the huge potential for energy efficiency in economies that might already have been reasonably efficient, and just how this can be thought of in a different way in terms of this alternative supply, if that helps to stress this idea. Perhaps then, just to finish with a very high-level assessment of what is the potential for energy efficiency, before we dig into this sort of specific topic of efficient motors in more detail. So this figure is an assessment of what is the outstanding or unrealized energy efficiency potential in a few different sectors. So the solid colors here represent so what has been done to date. What have we already done out of the full 100% of energy efficiency actions that we could do? And here in the shaded section, it shows what might be the open opportunities, this unrealized potential. What we see is that certainly in the sectors that we might think about for this presentation today, so commercial sector or buildings predominantly, and also in industry, is that there are large potentials, in particular in a lot of the countries for which this webinar might be most relevant, with emerging markets or industrializing economies. So there are large potentials for savings that can deliver both those mitigation benefits and also those other multiple benefits that I mentioned in previous slides. So that really sets the starting point for why, at a very, very high level, you should be interested in efficient motor systems. Perhaps just the last thing I would say is a little bit on the background to this, of where does this webinar come from. It's from a project that's been supported by CDKN, and it's involved the collaboration of the Energy Research Center of the Netherlands, that's ECN, together with, in Indonesia, the Ministries of Energy and Mineral Resources, ESDM, as the primary stakeholder and partner, as well as ministries of industry and planning, and a number of other private sector stakeholders. For example, importers of equipment or industry and government agencies connected to that. And that project had the goal of the last year or so to describe and study different government measures that could help to stimulate efficient motor systems in the country, in Indonesia, and also integrate what's going on in Indonesia now. There was already a really good starting point for energy efficiency there, and how could that be built on to realize additional energy savings. And there's also a project website that has some more detail on all of that below. But before, I'd like to then give the floor now to Jeffrey, who will get into much more detail of electric motor systems and the work that's been done in Indonesia. Please forgive just a small pause while we change the presentations over.
All right, thanks, Lachlan, for the introduction, and a very warm welcome to all attendees. Let me guide you through my presentation, which is specifically about electric motor-driven systems in Indonesia. And the content will be, first I will try to give you a general overview of electric motors and their systems. After that, we will quantify the Indonesian projects. We will look at some barriers taken from literature and from interviews in Indonesia. And at the end, we're talking about policy instruments to reduce the barriers, and that will be taken over by Martin in the last presentation. So let's go to a general overview of electric motors and their driven systems. Well, there are globally 195 countries in this world. On average, they consume like 81 terawatt-hour of electricity. Indonesia is a little bit more, and you can ask yourself the question where all this electricity consumption goes to. Very obviously, a lot goes to light. 19% is used to light our world. It's a very visible form of electricity consumption. It might be less known that actually 46% of electricity consumption flows to electric motor-driven systems, which is hard to see, isn't it? I mean, you just don't see it. It's 2.5 times more compared to lightning, and it's just used for keeping things turning and keeping things moving. That's it. An electric motor is actually quite a simple device, you could say. Well, they convert electrical energy into mechanical energy, and a few rather simple adjustments can already make an electric motor more efficient. Energy can be lost because of electrical and mechanical resistance that turns power into heat losses. And when these become less, the motor obviously becomes more efficient. Well, this already can be done by using thicker electric windings, better electric insulation, less space between the stator and the rotor. And if you're talking about lowering mechanical resistance, a better alignment of moving parts as bell bearings will do the job. Obviously, there are more important improvements possible as well. And what this figure shows you is the efficiency improvement of electric motors with a higher so-called IE rating. Internationally, there are 5 classes of IE rating from IE1 until IE5. IE1 is defined as the standard motor, and from IE2 onwards, motors are defined as high efficient. In this project, we also have introduced IE0, which represents the many unbranded, cheap and low quality motors, often imported from China. And from this figure, we can see that the difference between IE classes is actually larger for the smaller motors. If you would come from an IE1 1 kilowatt motor and you change it for an IE3 motor, the gain in efficiency will be about 13%. If you would look at a larger size motor, for instance 400 kilowatt, the difference only would be 3%. So many countries have introduced mandatory minimum energy performance standards for electric motors, shortly called MEPS. You could say since 1995 onwards, countries introduced MEPS at levels of IE1 or IE2, and over time countries have increased the level of their MEPS. China is an interesting one. China went to IE3 this year, and the interesting thing is that China actually produces most of the low quality IE0 motors, and since these are not allowed to be used in their own country, they're all meant for the export, and the majority of them ends up in Indonesia, and that's why Indonesia introduces this year a MEPS at the level of IE1. Motors, there are small motors, medium-sized motors, large motors. Let's have a short look about all these motors. The small ones are often integrated in so-called package machines like your household fan. The medium-sized motors are often ordered from catalogs, and they are or standalone or they are combined in a specific device like a compressor. We will talk about those systems later again. And the very large size motors, always to be found in the industrial sector, are often designed for a very special application, assembled on site and often integrated with other functions. Well, if a country then decides to introduce a policy program aimed at electric motors, then let's have a look at prioritizing such a policy program. You just saw all these motors passing by, the small ones, the medium ones, and the large ones. The small ones actually are most common. 90% of the global motor stock are small motors, and they are responsible for about 9% of the total electricity consumption of all motors. The medium ones are the most interesting one, only 10% of the global stock, but they are responsible for almost 70% of total electricity consumption. And the large ones are quite interesting as well, only a few of them relatively around the world, but still they consume 23% of total consumption, as well because they are running the whole year round, obviously. And in terms of putting a priority on a policy program aiming at electric motors, then I would say the medium and large size motors are most interesting. The small ones are still interesting due to the 9% consumption, but they need a different approach. There are many different types of electric motors. This is only to tell you that 80% of the global stock are three-phase induction electric motors, and they as well have clear international testing standards. In terms of sectors, within the industrial sector, an amazing 70% of total electricity consumption goes to motors with their driven systems. In the commercial sector, it's a little bit less, about 35% of total consumption goes to motors. And most of the motors are combined with pumps, fans, and compressors. And here you have the systems or the applications that we talk about. So conclusions: first, focus on the medium-sized electric motors. Start with the three-phase induction motor. These are to be found mainly in the industrial commercial sector. They're often combined with pumps, fans, and compressors. We're still in a general overview, and I would like to explain you something about the financial aspects. This slide shows you that over the lifetime of an electric motor, the purchase price is actually quite low. It says if you're talking about a motor that runs for 4,000 hours a year, which is not a lot if you think about the industry. In the industrial sector, motors might run the whole year round, but let's say 4,000 operating hours a year, and let's assume it has a technical lifetime of about 20 years, then 97% of total cost goes actually to the electricity consumption. That means that although higher efficiency motors are probably more expensive, they have quite a short payback time, and we will look at that later. Actually, we will look at that now, and then also related to the Indonesian situation. Since Indonesia has subsidized electricity prices, we asked ourselves the question, so what is the payback time actually for a higher efficiency motor in Indonesia? And let's take a test case within the industry, and let's go to the next slide. This slide shows you the relatively purchase price over the lifetime of a small electric motor, depending on running hours a year. The purchase price of lifetime for an IE0 motor, I'm not sure if you can see my mouse, I think so. Huh? Actually, well, anyway, it's there. The purchase price of lifetime for an IE0 motor is indeed 2% at 4,000 running hours a year, and that increases until 5% for an IE4 motor. So actually, yes, the purchase price of lifetime is relatively quite low. For bigger size motors, this actually becomes less, as can be seen in these two slides. So I do them again. Small motor, medium-sized motor, and a fairly large motor. So conclusions for the industry. Since we have a high number of running hours, the purchase price over lifetime for bigger size electric motors often is less than 1%, even with the present level of subsidized tariffs. And in the next slide, we can look at the payback time. So this slide shows the simple payback time in years when a medium-sized IE1 motor would break down, and you would replace it by a more expensive IE2, 3, or 4 motor instead of buying again the IE1. In this project, we continuously accepted the payback time of maximum 3 years, and what this slide tells us is that from around 2,000 running hours a year, the IE2 and IE3 motor will actually have been paid back within 3 years' time. And from, let's say, 2,500 running hours a year, that counts as well for the IE4 electric motor, and which would then actually be your best choice from a cost-effective perspective. And this beautiful, colorful Mondrian motor painting, as I call it, gives the same information for other motor sizes. And each colored square that does not mention IE1 represents a situation whereby a higher efficiency motor will be paid back within 3 years' time, depending on running hours a year and depending on the size of the motor. And this small yellow circle represents the conclusions from the previous slide. And then the conclusions are obvious for the simple payback time. Since we have a high number of running hours a year within the industry, simple payback times in most cases are below 1 year. And when 3 years is an acceptable payback time, i.e. 4 actually often is the best choice. Not shown in the previous slides as well, if you talk about mid-life replacements before the old motor breaks down, then you will find positive situations with a payback time less than 3 years as well. Just 2 remarks. In the Netherlands at the moment, IE3 is mandatory, and when IE4 is chosen, you can ask for a tax deduction. And on our website, you can find an Excel file that you can download, and you can produce the previous slides that you have seen yourself in different situations with different tariffs, different purchase prices, and so on. Okay, until now I spoke mainly about electric motors, the electric motor itself. Let's now broaden it to the driven systems behind it, because in terms of electricity savings, at the end it's all about the systems. And then we're talking about obviously the electric motor itself, the transmission and the couplings in between the motor and the driven system. We already touched on those driven systems as pumps, compressed air systems, and fan systems. And last but not least, on the left side, the variable speed drives, which are very important in this whole system approach as well. All right, let's take an example. In the upper drawing, you see a conventional pumping system, and below the same system is optimized. So what is optimized? First of all, the standard efficiency motor has been replaced by a high efficiency motor. You can optimize the coupling in between the motor and the pump itself can be a high efficiency pump. As said before, very important to replace the original throttle by a variable speed drive. And even the piping system that follows can have less friction. All of this leading to an enormous system efficiency improvement. And the next slide only repeats all these efficiency numbers that you just have seen, leading to an electricity reduction. So this is your saving of 41%, which is quite a lot, isn't it? On the left side, you see the efficiency improvement of the motor alone, that's 5%. And the other columns will tell you where the remaining part of this enormous saving can be found. Hang on, oh yeah, right. So in a policy approach introduced by a country, the motor can be targeted with the MAPs, the minimum energy performance standards, but the whole system approach needs actually additional policy tools that we will talk about in the second presentation. And there are many success stories, so it's not all theory. There are many success stories that you can find in the literature. We're not going through these, we're not reading it out, but efficiency improvements until 60% are often to be found. Let's now go to the Indonesian project itself and quantify it in terms of electricity consumption, electricity savings, and other benefits. We used a bottom-up and a top-down approach to calculate the electricity consumption of the medium and large size electric motors in Indonesia. The bottom-up approach was done by using import data. Indonesia is importing almost all of their electric motors, so everything that comes into the country in terms of electric motors is imported. I mean, they only produce a few ones themselves. And we used a top-down approach by looking at Indonesian statistics and taking into account literature information of which percentage of industrial commercial electricity consumption flows to electric motors, each subsector. And both calculations actually came quite close to each other. So this would be the total electricity consumption in 2014. And this way we were able to make an estimation of how many motors are actually running in Indonesia, only medium and large size. We use this to build up a business as usual projection towards 2035. And as you can see, the electricity consumption of both the commercial and the industrial sector will grow rapidly the next coming years. And yeah, this is the business as usual projection. Let's have a look at the present market share of IE classes in Indonesia. I've explained to you that Indonesia is introducing a MAPS at the level of IE1. The assumption behind it is that the majority of electric motors are at the level of IE0. Those are the unbranded motors from China. But actually we found out that maybe the largest share of electric motors in Indonesia are already at IE1. Still, you have 40% of these IE0 electric motors, but it's not like 80 or 90%. And this has some implications for the saving potential of the present MAPS. So at the moment, if you would put a MAPS at the level of IE1, you would only push the, let's say, 39% IE0 motors up into the IE1 level. And at the end, this will result in only 0.7% electricity savings. That's why a few times we have said, well, why not start immediately at IE2? One reason is as well that in the whole world, only 3 countries are at the level of IE1 at the moment. But I think they still will start at IE1, which is not a bad thing. I mean, introducing a MAPS in your country is already something. It's just a matter of increasing the IE level over time. I would say a bit conservatively, we have added 15% point to scenarios that include a system approach. So what would be the effect? If you take the business as usual scenario again, MAPS would lower it, the system approach would lower it until 20% savings. We did a lot of quantifications. We're not going through all these numbers. Just to explain you, as said, we calculated the electricity savings, which obviously has a relation with avoided CO2 emissions and a relation with financial savings for the industrial and commercial sector, and as well, maybe more Indonesian specific, governmental savings, since a large amount of these subsidies can be avoided. And to take all these numbers, to take them all together, this slide tries to explain you what the additional effect is of a system approach compared to a MAPS at the level of IE4 only. And it tells you this by giving you the multiplication factor. It goes like this. If you think about electricity savings and related greenhouse gas emission reductions, following a system approach would yield 4 times more savings. A system approach would be more expensive, but remember, still within an accepted payback time of 3 years. But since other equipment is more expensive compared to electric motors, the direct investment for the economy will be 9 times more. In terms of employment, it's not so difficult to install a motor, so you don't need a huge workforce. If you do a complete retrofit of your whole system, obviously you need more people, quite a lot more people. So we think that the employment effect will be 18 times more if you would follow a system approach instead of only a maps approach. Oh yeah, and in the past, Indonesia had 3 big electric motor companies actually producing motors in the country. Not sure when it ended, maybe 2 decades ago, and I suppose this will not happen, but I'm always thinking, okay, if you want to change 3 million replace 3 million electric motors and you import them all, why not producing themselves again, like you did in the past? But this might be more my personal thought. There are even more savings. Lachlan in the first introduction presentation mentioned it shortly. Since you save so much electricity, obviously you can avoid building some power plant capacity. We calculated that this program avoids 7 gigawatt of needed power plant capacity, and this equals actually half of the 15 coal-fired power plants under construction at the moment in Indonesia, and an enormous amount of investment. And I would say this amount of saved dollars would be enough for any country to introduce a policy program targeting electric motors and related systems. But it doesn't go by itself, otherwise it would have happened already. There are many barriers. Literature do mention many barriers found in other countries that are applicable for Indonesia as well. The next slides actually do mention a lot of barriers. We're not going to read through them one by one. You can go through them if you want later by using the handouts. I just mentioned one barrier each slide. There are barriers at the level of manufacturers and wholesale. For instance, customers demand for low investment cost and don't look at life cycle cost. You can find barriers at the level of planning and engineering. For instance, it's hard to find high quality engineering skills in Indonesia at the moment. You can find barriers at the level of investors and energy managers. For instance, often there is a large stock of old inefficient replacement motors available, so it's hard to choose for a new one if you still have motors laying around. And some additional barriers found specifically in Indonesia. In Indonesia, for instance, there is a large rewinding industry, which includes as well really low quality rewindings, but very fast. And obviously in the industrial sector, it's all about production. So if your production line stops for a few hours, that's a huge cost implication. That has a huge cost implication. So you want your motor to run as fast as possible again, and that's why there is a huge rewinding industry. But luckily, there are a lot of policy instruments to reduce these barriers, and this will be presented by Maarten in the next presentation. So let me try to hand over this presentation to Maarten. Give me a second. So Maarten, the floor is yours, and I mute myself.
Okay, thank you, Jeffrey, for your presentation. Good afternoon, everybody. I'm happy here to do the second part of the presentation. This will be about the actual policy tools we designed for the Indonesian program. The presentation has been prepared by my colleague Rita Werle from Switzerland and by myself. Just a short introduction, the two of us working together on international projects on motor systems. One important one is the implementing agreement on motor systems, EMSA, which I'm acting as operating agent, and Rita is acting as program coordinator. Also organizing a motor summit conference every 2 years. This year it will be held in Zurich in October. And the both of us are active on national programs in the Netherlands and in Switzerland. A few slides about EMSA, just a short introduction on this. EMSA is a cooperation of 6 countries. They work under the implementing agreement for E, which is an implementing agreement of the International Energy Agency. And the countries, Australia, Austria, Denmark, Netherlands, Switzerland, and the United States, are working together on the issue policies for electric motor systems. It runs since 2009, and we're now in the 3rd phase, which runs till next year, 2017. More information can be found on this website, motorsystems.org. One slide about the philosophy behind EMSA. What is the essence of motor systems policies? It is striving for market transformation. For market transformation, one needs to start with, on the global level, harmonized global standards. Only with global standards, this market becomes...
Martin, sorry to interrupt. I think you need to maybe press play on the PowerPoint. For some reason, I believe the audience is still seeing the first PowerPoint.
Should I start again then?
No, I think you can continue from where you are. We've only missed a couple of things,
Okay.
kind of background. But I think still just the screen at the moment. We just see just the PowerPoint application showing the first slide, not the actual running PowerPoint.
Okay, can you see now the different slides?
Not right now. I think if you could maybe go to the previous where we went to show application, and you could just click show my screen, and then it will just show your entire screen.
I just now clicked again. Can you see a change?
And unfortunately not.
No?
At the top on the right hand side beneath the play button, you could click show my and then change that to be just screen, and it will just show your entire screen of your computer, and then we'll see definitely the same as, yeah, now we see it.
Okay. Okay. So, okay, I continue, okay? Thank you. So, for this market transformation, we need on a global level the harmonized global standards, and then on a national level, successful policies to implement those global standards. Then, on a company level, one needs energy management systems and also audit systems. And then, in order to be able to implement those on a company level, one needs on a personal level tools and information. So all these 4 levels are included in EMSA's activities. Good. My presentation will be as 3 elements, 3 chapters, so to say. One is first policy guidelines, the publication of EMSA we're dealing here with. Then Indonesia, what does it mean for Indonesia? What program did we develop for Indonesia? And a short resume. Jeff already told us a lot about motor systems. I just have one slide to recapitulate this and to stress again the essence of motor systems. We're talking about the core is the motor itself. Sometimes we find a VFD converter to use with variable loads. Mechanical equipment, for instance, a gear, a belt, clutch, and the application itself, the pump, the fan, the compressor, and after that, of course, the duct system. The total of these components form the motor system, and only by optimizing these components in the most efficient way, one gets the opportunity to reach a very high level of energy efficiency. Research shows that in total, looking at the installed base at this moment, efficiency gains of 20 to 30% are possible. So it's huge. Also, research shows that when looking at installed base, this is an example of Swiss research in which more than 4,000 motor systems were investigated. It shows that a few things. A motor is a very reliable tool of technique. Once installed, it will keep on running when it's fed with electricity. So that's the normal practice in industry. Once a motor is installed, it's not touched again. As a result of that, many motor systems are very old. This slide shows, for instance, that more than half of the motors are older than their operating life expectancy. So this also means that, as just said again before, there's a huge potential for energy savings within motor systems. EMSA has produced the last years a series of publications focusing on successful policy implementation practices. A few are shown here. The Motor Policy Guide, Policy Guidelines, which I will talk about more later on. And one recent one is the one in green, Energy Efficient Roadmap for Electric Motors and Motor Systems, which was published in November last year. And this year we will publish a publication on policy guidelines for motor-driven units in two parts, one part this year and one part next year. All of this is to be downloaded from the two websites as displayed here. Some background. Why policy guidelines for motor systems? Well, one important reason is that there's no single instrument to facilitate energy savings. It always has to be a combination of instruments. That's one. Also, there are different elements that influence the decision making in industry. It's not only energy costs, but it's also labor costs, production costs, etc. So it's a set of criteria which makes the decision making in industry. Then cost efficiency alone is absolutely no guarantee for implementation. As Jeffrey already pointed out, that most of the efficient motors are yet already very attractive to implement, with payback times of less than 1 year. But it doesn't mean that they will be implemented by itself. There has to be done something extra. Then also within the companies there are different barriers in terms of procurement, install practices, etc. So looking at the total set of barriers, one can say that there's a mix of policy instruments needed in order to overcome the barriers for energy efficiency. And also one has to look into more than only maps or models in order to reach the full potential of energy savings of motor systems. The policy guidelines publication is a sort of cookbook. It's a cookbook of a sort of framework it offers for policymakers in order to make a strategy for electric motor systems. With this cookbook or guide, one can select a range of policies in order to come to the exact, most fitting set of policy measures for their country. The guideline is indeed also showing what one needs to take into account when implementing a policy instrument. It also gives some examples of successful policy experiences, and it gives some recommendations for implementation. This show is a sort of picture of the policy toolkit with the different elements within it. It shows 8 elements from financial incentives towards voluntary agreements and humanitarian programs. I will go into that more deeper a bit further. Important also is to stress that on a national level, the most effective policies stimulate action towards all the different stakeholders concerning electric motor systems. We're talking about on the national level, power utilities, but also the manufacturers, industrial users, and on an international level, the standard makers. Only with transparent, globally accepted standards on a national level, national policymakers can introduce maps. And they affect, of course, power utilities, the manufacturers themselves, but mainly also, of course, the industrial end users who have to follow those maps. So a policy, designing a policy on a national level has to take into account all these stakeholders. In section 2, I will focus on the Indonesian market and how we developed a program for the Indonesian market. Which policy instruments fit best into the Indonesian situation? First, I will follow the toolkit step by step and then focus some more in depth into the different tools. Instrument minimum standards. As Jeff already pointed out, I1 is now in the draft status and will get into force soon in Indonesia. As of yet, there are no plans for pump, fans, or compressors. Well, the recommendation is at this point is that get I1 into force as quick as possible, and also start planning to increase the level of maps towards I2 and I3. And at the same time, when introducing maps, one also have to take a look at or define policies for enforcement. How will market surveillance be done? Can you use international test labs, or how do you have to set up a registration system, etc.? One thing is to have a minimum energy efficiency performance level, but at the same time you have to define how you will do the enforcement. The second tool is labeling. For motors IE1 up to I4, labels are available, and it's a question of following the international labeling initiatives. You know, so it's quite easy in this way. Energy management is a third tool. In Indonesia, at this point, there is an energy law which is in place and affects big energy-using companies. They have to implement elements of energy management system. Our recommendation is, in this way, to improve the actual enforcement of this law to start with, and also to expand this regulation towards more companies. I will get into this later. Energy audits, also part of this law I mentioned. There are audits being done, but research shows also that this can be done better. The quality of the energy audits performed and the number of audits performed, and also the monitoring can be done at a higher level. So that's our main recommendation here. A company motor policy, meaning that on a company level you have a motor policy in place. As for now, we do not have any knowledge of examples in Indonesia, but we think it should be a normal, important element of the energy management activities within a company. So it should be integrated into the energy management system. Voluntary agreements as tool. This is as for now not used in Indonesia. A voluntary agreement means that agreements are made between government and industry associations and individual companies on actual saving targets, on the monitoring, and on the mutual benefits for the companies, what can be done in order to reach those energy efficiency goals, as well as for the government itself. So we think that it is beneficial for the Indonesian government to start a pilot with industry, including those main elements. And then motor systems can be an important topic within this system. Financial instruments. At this point, in Indonesia, electricity prices are partly subsidized, and no further tools are in place yet. And we say, well, it's when you expect companies to do more on the level of on the subject of energy efficiency, it's also very beneficial to help them with that in order to, in a way, to help them to invest in energy efficient measures. So it is wise to implement financial incentives to support this implementation. And that elements of that are grant schemes, tax incentives, a loan and guarantee instrument, and also, for instance, lower energy tariffs for companies that join a voluntary agreement. And then the last tool as part of the toolkit is raising awareness and information. For this, at this point, there are some programs in Indonesia on training programs on energy audits and motor systems. And we think that it's a very good thing to set up a information and awareness campaign. You can do it in cooperation with trade associations and also start negotiations or with between government and associations. And finally, you also have to develop the market for the energy audits and energy management. Because if you expect companies to become more active in these fields, you really have to invest in the market itself. Make sure that there's enough capacity within Indonesia to do the actual energy audits and to help companies to implement energy management systems. I will get more into it right now, making a summary of those recommendations. We have four main elements. The first one is join the global level of higher MAPs, of higher minimum energy performance standards. This is the first one. The second one is harvest the benefits of the current regulation on energy management, meaning improve the enforcement and also expand the regulation to a bigger audience of companies. And thirdly, add voluntary agreements. And fourthly, add supporting activities, meaning financial incentives, helping companies with training as factory staff and external specialists, and also start with a stakeholder platform together with industry. Maps. Global maps. This is the overview of the current situation. As you can see, three main regions in the world on I3 level: United States, Europe, China. I2 in Brazil, Turkey, also Australia, New Zealand. And I1, I've drafted it, made it red, Indonesia, which has to come in place this year, as we're well informed. So that's the current situation. A recommendation for this subject is that Indonesia should go to a higher efficiency level, meaning, as Jeff already pointed out, to prevent that Indonesia becomes a waste basket for low quality products from Asia. So you have to start right now in planning when will we make the shift towards I2, I3. And then also, Indonesia can start thinking about include other elements of the motor system, meaning defining maps for pumps, fans, and compressors. And as also already pointed out, when you when you start with maps, you also have to start thinking about how you are going to set up a registration, how are you going to enforce the maps, meaning a compliance regime, and also define what to do when you find somebody is not compliant. So this whole scheme has to be developed and put into place. Sorry. As I just mentioned, talking about maps, we're looking at the other main economic regions in the world, the US, the EU, China. There are also maps in place for pumps and fans, and in China even for compressors. US and EU are now working on maps for compressors, so there's a whole extra world ahead for Indonesia in making the next step for efficient motor systems. And they can, of course, profit a lot from the experiences within those regions. The second main element is the improve the existing regulation on energy management. The core element of this regulation is that it is mandatory for large energy consumers, and it affects, well, I must say it has the following elements for those companies. They have to appoint an energy manager, they have to formulate an energy conservation program, do some periodic energy audits, and report to the government what they have done per year. So that sounds good, it is good, but research also shows that there are many improvements possible, especially on the quality of what it's done, the quality of the energy conservation programs, the companies, on the level of monitoring, knowing as government what has been done, what can be done in the future, and also in the commitment and the level of implementation by the companies themselves. Maybe for those of you, just a short background on energy management systems. What do we mean by that? It's sort of organizational scheme implemented on a company level, and in fact it's just defining a series of processes by which one gets the possibility of continuous improvement day by day of their daily operations. So the plan, do, check, act cycle means that you define actions to improve your energy efficiency, then you start acting on that, implementing them, and check if they were successful. And that you do on a yearly basis. So implementing energy management means that you can improve your energy efficiency on a daily and yearly basis. So the actual benefits for the government and for the companies are shown here. On a government level, improving the enforcement of the regulation and also expanding it means that the government gets to know the affected companies, meaning they can also increase motivation and participation within those companies. Better enforcement and monitoring, and in that way multiplying the results of the regulation itself. And for companies, they have to get on a higher level, or in terms of setting saving targets, appoint energy manager, do the actual audits by certified auditors, so they have to do some capacity building within the company, and at the end implement the actual savings measures. Then expansion of the regulation, meaning that the Indonesian government can lower the threshold of 6,000 TOE per year, meaning that a larger number of companies will be affected by this law. The actual level of energy use per year has to be defined, meaning that some further analysis is needed for this, especially because we need to know what implications this has for monitoring and compliance by the government itself. But for sure is that it will achieve larger energy savings if this is implemented. The third element, introducing voluntary agreements. A voluntary agreement is made between government, the trade organization, and individual companies. And it means, in fact, it is a binding agreement which has benefits and compliance for both parties. Starting with industry, if industry signs a voluntary agreement, it commits itself to implement energy management system, to conduct energy audits every 4 years, to implement measures with a certain payback time, and to monitor those energy improvements. And then to report that to the government. The government commits itself to supply incentives to the companies in order to be able to do the audits, to implement measures, and also to monitor the improvements on a sector level. So from both sides there are commitments with also benefits. For the government gets entrance to companies, it gets to know the companies on a one-to-one basis, which makes it also easier to enforce the law. It will be cooperative enforcement, and it will improve the effectiveness of the current regulation. For the companies, the industrial companies, they get in return for the cooperation, for the participation, some training, some capacity building. They get the mutual understanding of enforcement, meaning that every company has to act on this. So if one company does it, they are sure that the other one has to do the same activities. So a level playing field is reached by that. Then they will, of course, profit from the benefits of energy efficiency activities. And last but not least, they can also get some recognition, show public customers that they are really active on this subject. And as a whole, as the Indonesian society, they will have CO2 emission reductions, the actual energy savings themselves. That's the main profit, of course. An example of the Dutch practice: in the Netherlands we have a long history of voluntary agreements. This slide shows the experiences in over the period 2005-2011. There's an overall efficiency improvement of 13%, which means 2.1% per year for the total of the participating companies. The graph shows 33 sectors, and it also shows the big difference between the actual savings per sector. On the left we see the best performing sector, which is education. On the right we see the worst performing sector. So this also shows that, for instance, you get as government quite some detailed information per sector. It also shows, to my opinion, that an even better performance is possible, and this is actually the current situation in the Netherlands, where government says, well, this is fine, 2% per year is okay, but on average, one has to do better. So it gives the government information on how industry performs, and also tools to adjust the actual performance. But also it shows that it works. It works. 2% per year is quite an achievement. For voluntary agreements in Indonesia, there are next steps defined. The main one will be involve potential partners, trade associations, and you have to define a scheme, including time path, the funding, the potential participation, and the cost benefit for government and industry. And here they can profit from experiences elsewhere in the world. Okay. Then we have the fourth element, which is supporting activities. First, some financial incentives are defined. I won't go into detail for this, but the bottom line is that if you want to increase the level of investment and participation in energy efficiency, one, as a government, has to also provide some funding, some incentives in order to make it happen within industry. Other supporting activities, information and awareness campaigns. Very important is training. A training program for industry, for the service industry too, on the level of energy management. What is energy management? How can you implement it? On motor systems as a main element within energy management measures. And the training setup itself. So for this, programs are available. The point here is to just devise them and start enrolling them. Other supporting activities for information and awareness are available too. There are tools available, best practices, the measure lists for companies, for sectors, specific sector, etc. So once the program is started, one can implement, one can choose the different tools within this information and awareness campaign. And finally, the stakeholder platform. This is meant as a platform to involve stakeholders in these initiatives, in the maps, in the increase the enforcement of the regulation, current regulation, and the information and awareness program and the voluntary agreements. Only when talking to those stakeholders and involving them in this program, the results will be the best. A short resume of the total program. This is the scheme as in a sort of different way presented. Three pillars and the supporting activities. The first one is the maps, strengthening the motor maps, thinking about maps for the other components. The second pillar, we expand and increase the effectiveness of the regulation on energy management. Third one, the voluntary agreement, and underlying the supporting activities, the financial incentives and information and awareness campaign. This is the total set of the recommendations for Indonesia, and this shows the program sort of visualized in practical terms. First, the pillar, the maps. On the left we have the regulation on energy management, and on the right the voluntary agreement program. And overall the incentives and the information and awareness campaign targeting at the companies within the covered with the regulation, and also targeting at the voluntary agreement companies. And this of course can be detailed further towards the actual needs by an Indonesian government. Okay, thank you very much. And I think I now hand over back to Lachlan.
Thanks very much, Martin, and thanks, Jeffrey, for the presentations. Yeah, maybe it's good to just add, I think there's a lot of information that we heard over the last hour or so, both about Indonesia specifically, but also about policy and motors more broadly. Maybe just to summarize what the project itself did over the last year or so, and that was to develop a quite detailed, you saw a quick summary of it there from Martin, develop a set of 3 pillars, 3 policy actions, together with the government in Indonesia for what could happen over the next years to take action on energy efficient motor systems, along with the supporting financial incentives and also estimated budget impacts and costs to develop that and to do that over the next years. And that's what the project has created now, and that sits with the Ministry of Energy as something that they will be taking forward. We do have just a couple of minutes for questions now, before we run out of time, maybe 5 minutes. What I would ask is, if you have been listening and are interested to ask something specific, please do type a question into the questions box that you can find in the interface. But I'll just in the meantime ask 1 or 2 short things to Jeffrey and Martin, and just to give you a chance to type something in if there is an open question. I guess I was going to ask Jeffrey first and then Martin second. Jeff, I know you looked at lots of different countries when you were looking for comparable experiences and what's been tried elsewhere, and I think we ended up looking a lot to European countries the government could pursue alone as a domestic measure. In that sense, many of the elements have a strong, I guess, business case for government action already on their own. But it's also currently designed or phrased in a way that it could seek for international support for parts of its implementation. For example, some of the financial incentives or relating to, say, technical assistance to run the program. And so I think the decision on that will be taken by, of course, the counterparts at the ministry. And I think that will determine how feasible or how likely it is to go ahead. If something's run independently from the Indonesia side, then I guess that makes it somewhat easier to control the timing of that and also how likely it is to proceed. If it's seeking international support through, say, a donor support or through a development partner, then that, of course, changes the timing slightly and takes things a little bit out of control. So I'd say that in the next 12 months or so, you wouldn't see this launching into action. But there is a lot of enthusiasm. This is not a project that's come external to the country. This was a request from the Ministry of Energy themselves to develop this. So there is a lot of enthusiasm to take action on this. And so in that sense, I think there's good chances of it being pursued. I don't know if you have anything to add, Jeff?
No, nothing to add. That's a perfect answer. Thank you.
Then from our side, we'd just like to say thank you to everyone who's listened in, and also, of course, to the project partners that have been involved in the project so far, and also to the support from CDKN. And of course, please do follow up and have a look on the website if you'd like to find the presentations or the recording of this. And I think there's also, you've seen the link to the project website, and you can, of course, seek any of us out if you've got further questions. We'd really welcome that. And with that, I'd like to hand over to Anna, if you're on the line, for some closing words.
Hi all, sorry, caught out by my own muted microphone. Thanks to everyone for coming. We will be putting the webinar recording and the slideshow presentations online on the CDKN website, so do keep an eye on there. But thanks for coming and sticking with us, and have a good day.